Hi, my name is Christian Ramos, and this is my Physics 2212 Lab 1 report on the charge tapes. So, a little table of contents. So, we're going to have an introduction, then we're going to go over the experiment, and then view the results, look at the glow script code, and then have discussion with the why and what if questions on that afterwards. So, the introduction, what's the purpose? It's to observe and record the transfer of electrons between two electrically charged tapes. We're going to use Coulomb's law, which is 1 over 4 pi epsilon naught, Q1, Q2 over R squared, and in second law, force equals mass times acceleration to find the charge on each tape. And this model specifically, for Coulomb's law, it's going to be Q squared because the Q's, the charges on each one, are going to be equal. And then for Newton's second law specifically, we're going to be using the gravity equation. So force equals mass times negative 9.81, which is the acceleration due to gravity due to the Earth. And we're going to be using the tape as point charges to model Coulomb's law. And then we're finally going to calculate the number of deficient electrons per atom on the piece of the electrically charged tape. And then one more thing to note is that when the electrical force coming from the held tape is equal to the gravitational force, then the tape is going to begin to float. So now for the experiment, so number one, we're going to have two neutral U tapes that are going to be ripped off of their respective base tapes, and that's going to create an electric charge in the two. And then one tape is going to be used as a bridge between two structures. That's going to be tape B in the model, and it's going to be concave due to the gravity of the Earth. And then the second tape, tape A, is going to be slowly raised towards the tape bridge until the tape bridge begins to float, and it's no longer going to be concave, and the electric force is going to be equal to the gravitational force. And then we're going to measure the separation distance between the two tapes. And just another note, the system is going to be tape B, so that's going to be the one that is first concave, and then it's going to start floating upwards, and then the surroundings are going to be tape A, which is the tape that we're moving up to the bridge and the Earth. So that's going to be the electrical force of tape A acting on tape B, and the gravitational force of the Earth acting on tape B as well. And then the initial conditions, we're just going to have tape B suspended across the two structures, and only the gravitational force is acting on it. Our results. So the tapes repelled each other. The tape began to float at a separation distance of 0.03 meters. And then the U tapes were positively charged. We found this because they were attracted to the negatively charged pen. Each tape has a charge of 1.4 times 10 to the negative 8 coulombs. And then we found that because we plugged in the gravitational force equation before the tape was used. And then we had we equaled that to the electrical force, which was Coulomb's law, and then we found the charge of the tape after that, and then the electrons lost was just the net charge of 1.4 times 10 to the negative 8 divided by the charge of one electron, which is 1.6 times 10 to the negative 19, and then we found the number of electrons lost, and then the atoms lost is going to be 2.9 times 10 to the negative 6 atoms. The glossip code, so we just plugged in all of our dimensions, our forces, our charges, all that into the glossip code that we made. And then as it shows on the right side, it was very, very similar, nearly identical to what we had in the results before. The charge on each tape is 1.4 times 10 to the negative 8 coulombs, same as before. The efficiency of electrons on one piece of tape was 8.75 times 10 to the 10th, so that's the same as before. And then there are 2.901 times 10 to the 6th atoms for every electron of a piece of tape, so it's all the exact same as it was in the experiment. So some possible errors in the charge of the tape could be due to my hands touching the tape and moving the tape, the electric force of the books on the supporting bridge tape, tape B, and then the electric force of my body or the table in which the books were on. So what if a proton and electron charges, what if they were flipped? So there'd be no change, since they're still like charges, they would still repel and opposites would still attract. Why is it important to handle these tapes as little as possible? This is just to keep the tapes charged, since touching the other objects causes the tapes to lose some of the charge as they gain back electrons onto the tape. Also, the grounding effect can play a role when as touching, let's say my hand, for example, and my eye am like on the earth, touching the earth.